Hello, this is the homework tutorial for page 83. That'd be numbers 9 through 13, 18, 20 through 23, and 30 through 35. So an abundance of problems. The good news is the last set of problems on this is there are just sums and differences. So things we've done in the past. Hey, remember on those? Because I'm not going to help you with them. You have to have a common denominator when you add and subtract, and the denominator stays the same. It tells you what size pieces you have. Okay. Kicking this thing off. It's Thursday when I assign this, okay? So if you're tuning in, you're either doing this early or you've heard me all week saying the same things over and over and over again. And that would be about division and how it's the opposite of multiplication. But here's the deal. We say division is the sharing operation, okay? It helps us split things into groups. And here's the neat thing about it. When we divide, we usually say, okay, I'm going to take what I have, what I've got, and split it up into this many groups. I want to know how many would be in each group. Or, on the other hand, we say, okay, here's what I've got. I want to split it up into groups of this size. How many groups can I make of that size? So it kind of flips around. However you want to chase after it, it depends upon the context of the problem. So yes, I think it comes back to this whole story problem thing. But you know what? I'll look at numbers 9, 18, 20, and 21 with you. Actually, I'm not going to do these with you, but I'll help you set them up. By the time we get down to these, it should make more sense after approaching these. Okay, now starting with number 9. Here's the deal. You read the problem. There's a context with this problem. And what we're attempting to do is split up some chocolate. Now, here's the weird thing about this. All week, people get used to taking whole numbers divided by fractions. Divide by fraction. Divide by fraction. What if we took a fraction and divided it by a whole number, okay? So don't get thrown by this, but that's what we're attempting to do here. And here's what I'm going to bring up, okay? Basically what we're saying is there are 8 students on number 9, 8 students, and we have a half a pound of chocolate. Our job is to take this half a pound and split it up among the 8 students. I want to know how much should I give each person. Here's what I do know, though. When we write a division sentence, the very first number is always what you have. Okay, so do not make the mistake of doing this. I will show you the number one mistake people will make on this. They will write 8 divided by 1/2. I say, wait, what does this really mean? It's saying, okay, I have 8 students. I have 8 students, and I'm splitting them up, okay, into groups of the half size, okay? How many groups of the half of a student could I make? That's gross. That's disgusting. Why would you split a student in half? Okay, here's the deal. I'm not splitting the students up among the chocolate bars. The chocolate is not eating the students. The students want to eat the chocolate. So here's what I know. I have a half a pound of chocolate. This is what comes first. I have a half a pound of chocolate, and I'm splitting it up into how many groups? Well, let's see here. I want each student to get some chocolate. 8 groups, because there are 8 students. So here's the deal. I say, okay, I have a half a pound of chocolate. I'm splitting it up into 8 groups. The question here is, how much is going to be in each group? Oh, yeah. So I'm looking for the answer to this. Now, if I haven't beat you over the head with it enough, I'm going to say it again. When you divide with fractions, you just rewrite it as multiplication by the reciprocal of the second number, the divisor, okay? So here's the deal. People like to argue with me all the time. Well, 8's a whole number, Mr. A. That doesn't have a reciprocal. Only fractions have reciprocals, because then you flip it, you know. And I say, well, you know, you could make 8 into a fraction. So here's what I know. You can make any whole number into a fraction. Just plop a 1 underneath it. So I think that original sentence says the same thing as this. And furthermore, I know that this would mean the same thing as taking what I have times the reciprocal of 8 over 1. Hey, 1/8. So here's the neat thing about it. You multiply straight across. And even furthermore on this, I said, oh, okay, 1/16. I don't think you could simplify that. Now here's one thing that's really important to me, and it should be to you also, and it's this, okay? You have to label your answer. What were we talking about? Well, we had 8 students. We're splitting up a half a pound of chocolate among 8 students. We want to know how much chocolate should they get. Okay, they should each get 1/16 pound of chocolate. You notice I wrote LBS. It's an abbreviation for pounds. Okay, but you know what? I have no problem. If you're tuning into this broadcast, hey, number 9, the answer is 1/16. I got to see the work. I have to see it. If you just write 1/16, I'm not going to believe you. You just found it somewhere. It didn't come to you in a vision. I know this. Okay, I don't believe in that. All right, hey, that being said, number 18 is kind of a reflection of number 9. It has nothing to do with the fact that 18 is twice as big as 9. I don't know why I just came up with that, but I'll tell you what. What we're saying here is there's a young lady, and apparently maybe she works at a vet clinic, I don't know, But there are 12 cages. She feeds rabbits or something like that, and she has 1 1/3 pounds of food, okay? So she's got to get this food split up among the cages, and we don't want to be unfair about it. We don't want to give one of these animals 1 whole pound and split up the other 1/3 among the rest of them. So we want them all to be equal size amounts. Here's what I know. We're splitting the food up among the cages. We're not splitting the cages up among the food. That just sounds weird, and that would just be really, really weird. You'd have to get like a superior saw or something like that. And food don't eat cages. So here's what I know. We're splitting up this food among the cages. When we write this sentence, we're taking what we have, which was 1 1/3 pounds of food. Hey, it doesn't hurt to label it. We say 1 1/3 pounds, lbs. Okay? And we're dividing that up into 12 equal-sized groups among 12 cages. We want to know how much per group. Here we go again. When you divide with fractions, you change it into multiplication by the reciprocal of the second number, the divisor. So here's what I know. That's not a fraction. And neither is that. I know it's easy to turn 12 into a fraction. That's, wow, I didn't even bust a sweat. But how do you turn a mixed number into a fraction? Recall that. You take the whole number times the denominator, times 1 times 3 is 3, and you add that on to the numerator. So if you're adding that to the numerator, last time I checked that was 4/3. We have 4/3 pounds. We're splitting it up among 12 cages. That is 12 over 1. Rewriting this, sorry that it's crooked. That would be 4/3. Instead of divide, we'll take it times the reciprocal of 12, which is 1/12. Hey, to top this all off, you just multiply straight across. I'd say 4 times 1 was 4 last time we all checked, and 3 times 12 is 36. Now, I look at that, and you should be looking at that, and after getting on your case all the time, you should be thinking, I need to simplify that. Well, I'll tell you what goes into 4 that also goes into 36, besides 1, and besides 2, because they're both even. 4 does! 4! Let's divide them both by 4. Hey. Okay, 4 goes into itself 1 whole time. 4 goes into 36 9 times. Question is, how do I label this? What were we doing? We were splitting up food in pounds among 12 cages. So if I take this much food and I split it up into 12 equal-sized groups, there should be this much in each group. So this should mean each cage gets 1/9 of a pound of food. Now, like I said, 21 and 20. Just like what we're looking at here. Basically, what I'm trying to get across to you, if you haven't noticed already, and you haven't watched the last video already, and you haven't been in class all week, when you divide with fractions, you multiply by the reciprocal of the second number. Okay, I get it. You've said it a million times. So here's the deal. Let's just change this instead of 10 divided by. How about 10 times? 10 times what? Hey, flip these around for me. 3 halves. Wait, you can't multiply unless they're both fractions, right? Hey, I got you covered. We'll put 10 over 1. Now you can multiply straight across. And yes, you got to simplify. I'm not going to take it unless you simplify, because it's a not a meaningless number, but who likes to say, yeah, 30 halves. Can I have some of that, please? 30 halves of what you got? No, they don't like to do that, because it doesn't make a whole lot of sense in normal conversation or rationalizing things. Now, hey, I'll tell you what, number 21, you might be saying, but these aren't fractions. Look, quit crying about it. Make them fractions. Wait, when you divide with fractions, yep, I'm saying it again. You multiply by the reciprocal of the second number. So instead of 5 wholes divided by 37 wholes, we'll take 5 wholes times 1/37. Multiplying straight across, here's the deal. Your answer, I want it to be a fraction. I wanted that. Oh, and by the way, if you're thinking this is just going to be 5/37, yeah, I know. Isn't a fraction kind of a division problem? 5 over 37, doesn't that mean 5 divided by 30? I love division, and I like fractions, because when people say, hey, Mr. A, what's 5 divided by 37? Quick, I just go, it's 5/37. Yeah, so, I'll give you a new one. How about 9 divided by pi? Ooh, there's a hard one. It's 9 pi. That's just what it is. Look, don't make it harder than it needs to be when you divide with fractions. Be safe. Multiply by the reciprocal. Good luck on the homework. You'll get it done.